Hi there, my name's Andy Rawsthorne and I'm Head of School for the School of Engineering and Built Environment here at Sheffield Hallam University. As a student with us, you'll be treated as an engineer from day one. In our school, we're about opportunity. Opportunities to use equipment and facilities such as you'll see in these videos. Opportunities to apply these in real projects, in project-based learning modules. And opportunities to work with industry and develop your employability skills.
So this lab basically acts as a stepping stone. It's the base point for us going into other labs and further learning. So we'll take the information we've learnt in this lab and then we will use it in other labs to look at maybe material fatigue and things like that.
In this lab, we do a range of activities, including radiation detection, gravity measurements, electronics, and other lab analysis. This year, for my final year project, I've been working with radiation detection, using dosimeters that I know that they use daily in the nuclear industry.
So in this wind tunnel lab, we use the wind tunnel system using a computer to record data of several aerodynamic surfaces. That can include aerofoils, so like wing surfaces or models of bigger surfaces scaled down. We then take the data from the computer and process that to look at how it affects it. This helps us relate to industry by where they use the larger wind tunnels, we use a small one and get the real hands-on experience of processing and testing. They might do it on large aircraft or on space applications, whereas we do it here with this, giving us processing and real experience that we can take on into industry.
We use the Merlin Excalibur 2 flight simulator. It allows us to input our own parameters to simulate an aircraft. It helps our learning because it allows us to give a good rendition of what a plane would be like if we were to design it ourselves and what parameters impact the certain stability within that aircraft. In terms of pilot and flying ability, it gives a good understanding of what it would be like to fly in certain conditions because the simulator allows for different turbulence, visibility, taking off from different places, different payloads, so you've got a good understanding in the fundamentals of flying.
So in this lab, we have the latest in industrial standard cutting-edge equipment, from controllers that can control industrial processes, to industrial robots, to our Industry 4.0 system. All the equipment we have is the same equipment that students would see in the world of work. So when they actually finish the courses or go on to placement, they have familiarity with that. It is the latest, it is cutting edge, and they're able to engage and quickly make an impact in the workplace.
So we've got a couple of different activities we do in this lab. We've got a refrigeration cycle, which we're able to look at in real life and compare what we've done in lectures to. So a lot of what we do here is just scaled down versions of industrial practices. So gaining understanding visually of what happens with these processes now means it'll benefit us when we go into industry and have to deal with one 50 times the size.
As engineers, we design solutions. Those solutions often are products that are made out of materials. And what we do in this lab is explore the mechanical properties. Understanding mechanical properties of the materials allows us to select the correct material for the application. Getting the right specification means that we can get the lightest, strongest, toughest, best product out.
Well, we've got a variety of conventional machines in here, such as lathes, milling machines, etc. All the students have to have a safety induction before they're even allowed to use them. We also have a range of CNC machines, including a state-of-the-art 5-axis machine. The machines we have are all found in industry, and the technicians, they all have the experience to pass on to the students for when they enter the world of work.
We do embedded electronics here, we do computer-aided design in here, and it allows our students to design a whole range of different types of embedded systems for a variety of industrial applications. This will allow our students to have experience of industrial standard software that will allow our graduates to move into the industry for a whole range of different sectors, whether it's the automotive, aerospace, or embedded electronic systems. In our electronic lab, we have a broad set of equipment. They include, for example, a spectrum analyzer, a variety of digital oscilloscope, signal generator, etc. And the devices are top of the range, and they are broad. Our electronic lab is available to our students to be able to come in their own time, as well as being supervised to gain practical and hands-on experience and improve what they have learned from the lectures.
This is the power and transmission lab, so it's related to electrical engineering. So we will do experiments on power generation, power transmission, and power distribution.
Well, there are a number of activities that we do in the lab, and most of them complement to the automotive industry. We have taken apart an AC compressor, which helps us understand how they work better, and we've also done a couple of measurements on the steering system jig. I assure you, everything that we need to learn is in here, and it's broken down into tiny bits of information that would make up very important parts of the automotive sector, and I believe that this would go a long way in us learning about the industry.